The topic 4 is about bipolar junction transistor. It's a very important active device of electronic uh, in the electronic devices. Bipolar junction transistor is also known as a BJT. Uh, a bipolar junction transistor is basically a three-terminal semiconductor device that consists of two PN junctions. We have three types of materials: P-type, N-type, and P-type material, using which this BJT is being constructed, and it consists of two PN junctions which are able to amplify a signal. It is a current control device, and the three terminals of BJT are base, collector, and emitter. This is how physically a transistor looks like with three terminals, and these are the symbols of PNP bipolar junction transistor and NPN bipolar junction transistors. The arrow indicates the direction of the current flow, and with the help of an arrow, we can differentiate between NPN and PNP transistors. If the arrow is inwards, it's an PNP transistor. If an arrow is outwards, it's an NPN transistor. Here we can see that this is a structure of an NPN transistor where the emitter is of N region, and the base is of P type, and the collector is of N type, and a junction between emitter and base is known as emitter base junction, and the junction formed between the base and the collector regions are known as collector base junction, and the three terminals will be taken out of the three regions of this transistor and named as emitter, base, and collector. The three configurations of bipolar junction transistor are common base configuration, common emitter configuration, and common collector configuration. It depends upon which terminal we are taking it as common in both the input and output circuits. Each of the configuration has different characteristics and different applications as per the characteristics. The next here I'll be explaining you about the common base bipolar junction transistor. This is a circuit for a common base bipolar junction transistor, wherein the emitter is being connected to the positive terminal, and the base is being given the negative terminal. In this way, the emitter base junction is forward biased, and this is a PNP transistor. So P-type collector is being given the negative is being connected to the negative terminal of the supply, and the positive is being connected to the base terminal. In this way, the collector to base junction is reversed bias by using this VBC and VBE. These two voltage sources are used to forward bias emitter junction and the collector bias, reverse bias the collector junction. And this IE represents the emitter current, IC represents the collector current, and IB represents the base current. Excuse me. These are the characteristics, input characteristics of a bipolar junction transistor, which is being plotted for different values of VCB of 0 volts, 8 volts, and 18 volts. Initially, when the input voltage is less, it's below the cut-in voltage, the current will be 0, and as the input voltage exceeds the cut-in voltage, the current will start increasing linearly with respect to the input voltage. The next one is the mm, uh, output characteristics of common base bipolar junction transistor. It's been plotted between the output voltage and the output current. We can see that these are the different output characteristics of common base bipolar junction transistor for different values of emitter current of 0 milliamperes, 10 milliamperes, 20, 30, and so on. The region which is below this IE of 0 milliamperes is known as the cutoff region, and this region which is being and the dashed line is being shown over here, and from this dashed line to the region towards the left side is the saturation region, and the region from this dashed line still this IE equal to 0 is known as the active region. In this way, the output characteristics are being divided